Cause some of the materials dry, and B, I expect violence to erupt later. So you will be lulled into a sleep and be awoken by raucous violence. My name is David Nally. Among other things, I am a contributor to the Fedora project, and Fedora tends to be one of the distributions that is heavily using SELinux and has for a number of years. We're also one of the few Linux distributions that turns SELinux on by default. Here's some contact information for me. I expect your flames after this, we'll get started. I should note that you should have the assumption that this is not a developer-oriented talk. I will not tell you how to write SELinux policy. I am assuming that you know what SELinux is, though, and this should be from more of a system administrator perspective. I also assume that you don't like SELinux, or you think that you don't like SELinux. You're probably running with it disabled. You're attending this talk to heckle me because you hate SELinux. It's pissed you off and you're not going to take it anymore. And I suspect that a small subset of you came armed. So, I read a quote back around 2006 from someone who I believe to be Seth Godal. I tell him that it's him. I don't know if it really is him. But he said that that the talk about disabling SELinux by default reminds him of the talk when they started turning on firewalls by default. And that essentially it was too difficult. People couldn't understand it. People wouldn't use it, and they would be turning it off by default. And you know, if you started from a beginner position and started playing with IP tables, you can probably understand some of that frustration, because you can understanding things like chains and forwarding and NAT rules can be difficult. And SELinux can certainly be difficult, but it is not worthless. So just to talk about some interesting facts, most people know that the NSA started work on SELinux. They still contribute heavily to SELinux. They are certainly not the only contributor anymore. There are a number of other large partners, IBM and Red Hat being some of the largest. Most people do not use it as mandatory access control. When the NSA wrote it, they wrote it to deal with systems that have classified information. And essentially that is the multi-level securities implementation of SELinux. And while you can enable that on any machine that has SELinux running in the kernel, virtually no one does. And if you think the SELinux that you're familiar with is a headache, you cannot begin to comprehend how difficult mandatory access control that they actually wrote this to implement is. So I've got a pretty heady statement below that, which is that there's been only one remotely exploitable vulnerability that SELinux would have stopped. Red Hat did a study of all of the vulnerabilities that were remotely exploitable and affected Red Hat Enterprise Linux 5. And only one of those would not have been stopped by SELinux if you had logging and enforcing mechanisms. That's an interesting perspective. So just to cover some ground rules, and by the way, this is going to be, a lot of this is going to be going pretty fast. If I don't explain something to your satisfaction, please ask. You can interrupt me, it will not hurt my feelings. So the traditional access controls in Linux have three different operations. You can read, you can write, you can execute. And there are three different people to whom that applies: the owner, the group, and everyone. And so you can take a look at file permissions and determine what you can do. So the second line here is my private SSH key, and you can see that I am the only person on the system that should be able to do anything to it, root excluded. And the top line, of course, anyone can read SE password, but only root can modify just modify, read and modify. The problem is that's not enough. So, take for instance, can Firefox access your secure shell key? When you're running Firefox, you're running it as your user. If you go back and take a look, your user can read and write to your secure shell key and execute. And you're running Firefox as your user. So if someone has a JavaScript exploit or a Flash exploit in your browser can go and pick up your secure shell key. Those of you who use secure shell keys, especially without passwords, just started getting scared, or you already do it, one of the two. So there's only really two levels within Linux. There's the user and there's root. And access control is discretionary. In other words, it can be changed. It can be changed on the fly. And for instance, the user, I could have changed my secure shell key to be readable and writable by anyone. And in general, it's just not granular enough. It doesn't get down to, yes, I'm running as a user, but I shouldn't be able to touch secure shell keys. So SELinux says there are properties. And it identifies 4 sets of properties per file or process or object. And then a policy is applied to it. And the policy is loaded at boot. And it's relatively rigid. And the policy is not designed to really be changed on the fly. There's some exceptions to that called booleans that make it a little easier to apply different paths in the policy. And the default is to deny. So you will not be allowed to do anything unless the policy explicitly grants you permission, or you change the security properties on the resource to match the policy. And that deny by default is what frustrates most people. That's where they run into it, because most likely no policy exists for that situation. So SELinux has 3 different types of access control. There's role-based access control, which is a little heavier than type enforcement. There's multi-level security, which I talked about a little earlier. And we're not going to talk about either of those. We are going to talk about type enforcement, because that's the type of enforcement that most Linux distributions are shipping with. And you'll see even with type enforcement, it's pretty complicated, and it gets a little more complicated with the other 2. So security context. These are essentially the attributes that are added to a file when you have SELinux enabled. So you'll notice that the attributes are separated by colons, and there's user, the role, the type, and the level. And you can largely ignore everything but type in most SELinux situations. If you want user or role or level to come into play, you're looking at moving up to a different type of enforcing. You can pull this. You can look at the file context by passing the capital Z switch to LS, and it'll show you all of those. But the one that you care about is type, and you can see that our type is SSH home T. And by convention, although there certainly is no rule, they are generally adding the first letter of the type of attribute to the attribute itself. So the underscore T is supposed to, by convention, tell you that it's type, even though they expect that you know that it's that way. So there's one of those for every. There's one of those for every file, every process on your machine. So if you have SELinux enabled, and You can look at that with ls-z if you want to see what it is.